So now that we've seen how to graph log functions, we're going to look at graphing exponential functions. Okay, so since these are inverses of each other, they're going to look kind of similar. So they'll have the same basic shape. They'll just be oriented in a different way. So we're going to start with a basic example. Y equals 2 to the x. Okay, and you can already see that this is just the same configuration that we had before, only last time I was looking at the log base 2 of x equaling y. Okay, and they're very similar to each other. Actually, what we did on the other one is we put in the numbers that we would pick for y and used our exponent, in order to figure out starting points for our base function. But now we're actually going to put those same starting numbers in for our x, and we're going to be able to get out our y values. So 2 to the negative 2 is 1/4, 2 to the negative 1 is 1/2, 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4. Okay, so here's going to be my base function. So we're going to go x2 up 1/4, back 1, up 1/2, back none, up 1, over 1 up 2, over 2 up 4. Okay, and if you remember the log function, so if I graph this log function on here also, okay, that would be, we're going to have this kind of a deal. Yeah, because 2 to the, or log base 2 of 1 is 0. Log base 2 of 2 is 1. Log base 2 of 4 is 2. So these are two graphs. Okay, and they're inverses of each other. And they look like inverses of each other. Because if you remember what inverses look like on a graph, they're reflected over this line, y equals x. Okay, so their inverses are reflected over this line. Okay, so now let's look at transforming our graph. Okay, and then we'll do another couple examples just to see how our base function changes. So actually, let's do that right now. Let's see how our base function changes if I've got a different base. So let's do 3 to the x. Well, then if I put these same numbers in, okay, negative 2, negative 1, 0, 1, 2, 3 to the negative 2 is going to be 1/9, 3 to the negative 1 is 1/3, 3 to the 0 is still 1, 3 to the 1 is 3, and then 9. So we're always going to pass through this point. It's 0, 1 for our base function. And then the rest of it is just going up steeper. So that'd be up here. Still going to that point. Now I'm at 1/3 and 1/9. Okay, so it's just a little bit steeper graph. Still passing through this point. Okay, now I've got a horizontal asymptote, whereas the log had a vertical asymptote. Okay, so now let's look at our graph transformation. Okay, and I'll do it with the table and just from the graph. Okay, so our transformed x movement we'll put here, our transformed y movement we'll put there, and then we'll still use 0, 0 as our starting point for our movement. So again, we're going to have to factor. Okay, you never want to forget to factor, so I'm going to have negative 2. Now, if I factor negative out of this, I'm going to have x minus 3 plus 4. Now, the exponent is where the x is, so all the stuff that's in with the exponent, that's what's affecting my horizontal movement. all the stuff that's outside, like this negative sign and the +4, that's affecting my y movement. So my starting point now is going to be to the right 3, 1, 2, 3, and up 4. Okay, so this is going to be my starting point. Okay, I don't want to put a dot there because it's not actually going to be on my graph. That represents this point here, my new origin. Now, instead of going left 2, okay, I'm going to go right 2. I don't have a multiplier on here, but I do have a negative sign, so that means I'm going to go to the right 2. And instead of going up a fourth, I'm going to be going down a fourth. Okay, so this 2 is not a multiplier. A multiplier would look like this if I had like a negative 3 times this thing. Then I would be multiplying my up-down movement by 3 and switching it. But since I've just got the negative here, all I'm doing is switching the direction. So I'm going to go down a fourth. Instead of going left 1, I'm going to the right 1. Instead of going up a half, I'm going down a half. Okay, so I'm just switching the sign on all of these. Oh, -2 here. So from my start point, I'm going to go to the right 2, down a fourth. I'm going to go right 1, down a half. I'm going to go none and down 1. I'm going to go left 1 and down 2, left 2 and down 4. Okay, so it kind of ends up looking like a log function, right? Because if you think about it, my horizontal asymptote has moved up 4 spots, so this is my horizontal asymptote now. So I know I'm going to be approaching that as we come this way. Okay, so it's been flipped down, it's also been flipped left-right. So as the blue one was going up to the right, now we're going down and left. Okay, and we're getting bigger and bigger that way, as where this was getting much bigger, much faster as we went to the right. Now we're getting much lower as we go left. Here on the blue one, my left side approached the asymptote. Okay, and it was on top of the asymptote. Since I've flipped left, right, and up, down, now my right side is approaching the asymptote on the bottom. Okay, so that's how you graph the transformation. I want to talk about E a little bit more because E is part of logs and exponential functions. So just remember E is this number. It keeps going on forever, never repeats. So e to the x is going to be graphed the same as a to the x. So I'm going to have a base function the same way. So that same number that I always pass through, 0, 1, is going to be on here. If I put in -2, that's 1 over e squared. If I do -1, that's 1 over e. Okay, so this is 1 over 2.7 squared, okay, which is going to be more than 2 squared, not quite 3 squared, okay, but it is closer to 3 than it is to 2, so this will be, you know, about 1 over 7.5, say, as a rough guess. So, you know, between 1/8 and 1/7. This would be 1 over 2.7, which is about, you know, not quite 1/3, but more than 1/2. And then if we put 1, we get just e out, which is 2.7. If we put in 2, we get e squared. Okay, so if I square this, you know, the square of 2 is 4. The square of 3 is 9. This is closer to being 3 because 2.7 is closer to 3, so it's going to be somewhere close to 9. I can actually show you what it is, but these are the things that you can kind of do in your head when you're making a rough graph. If I really want to know what e squared is, okay, there's the e squared button above there, and I want e to the 2. Okay, it's about 7.4, okay, and I said my original guess was about 7.5, so pretty close, just, you know, gauging how close it is to 3 compared to how close it is to 2. and judging that distance between 4 and 9. So I can plot my base function on here. Okay, 0, 1, -2, and that's about here, and about here. If I go over 1, that's up 2.7. Over 2, you're up 7.5. Okay, give or take. So this is my base function. Now if I start transforming that, okay, I don't have anything to factor out. This has been moved to the right 1 and down 3. So here, this is moving right 1, down 3. This is my new kind of starting point. Let's change colors here. So from there, instead of going over 2, actually I'm still going to go back 2. But now instead of this, okay, which was about 1/8, okay, a little less than 1/8. So now I'm going to go over twice that, or up twice that much. Okay, so that'd be, a little less than 1/4. This is a little less than 1/3, so now I'm going to go up a little less than 2/3. Okay, my x movement's going to stay the same. This is going to double. This would double, so 2e, which would be, 2 times 2.7 would be 5.4 or something. E squared was about 7.5, 7.4, so if I double that, that puts me at 14.8. Okay, so just rough estimates here. I mean, we're sketching the graph. It's not an exact graph. So let's see. So from here, I go back 2, up a little less than 1/4, back 1, up a little less than 2/3, over none, up 1, over 1, up 5.4, over 2, I go up 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 14 is going to be way up there somewhere. So remember, this affects the y, so it should make it climb faster. It's stretching it in the y direction. So if my original graph was like this, my new one should be steeper. Okay, which it does. Looks a lot steeper. This is my horizontal asymptote that I've got. So approaching that, and I'm coming up quite a bit steeper, which I just can't seem to do with this pen. Okay, quite a bit steeper compared to my other one, which is more of a naturally feeling steepness. Okay, so that's graph transformations as they relate to exponential functions. Same rules. The big things, make sure you're always factoring the inside part here. Okay, and this is all x movement stuff. The outside things is all y movement, things like that.